ሰላም ተማሪዎች እንደምን አላችሁ? እኔው ነኝ የ10ኛ ክፍል ፊዚክስ መምህራችሁ ከሉሲ ብሪጅ አካዳሚ። ዛሬ የምንመለከተው ሴክሽን 1.3 ቬክተር አዲሽን ኤንድ ሰብትራክሽን ይሆናል ማለት ነው። ትምህርታችንን ከመቀጠላችን በፊት ግን ዌብሳይታችን lucyBridgeacademy.com በመግባት የተለያዩ ሾርት ኖቶች፣ ጥያቄዎች ወይም የጥያቄ ባንኮች በተጨማሪም ከ5 በላይ ቋንቋ መረዳት የሚችል የኤአይ መተግበሪያ ፕላትፎርምን እናም የዩቲዩብ ፔጃችንን ሰብስክራይብ ያደረጋችሁና የቴሌግራም ቻናላችን ጆይን ያደረጋችሁ ሐሳብ አስተያየታችሁን አጋሩን። ወደ ትምህርታችን In this case, let's see some basic point regarding that about the vector addition and their basics. Okay? So by having this, that's we know that on the previous class we know that vector addition, which is considered by having that what? Its magnitude and direction. It is dependent on that of how we can add using that of the vectors magnitude and what? Direction. Because the vectors are quantities which can have both magnitude and direction. That's unlike scalars, we cannot simply add or subtract or multiply vectors having that of what? Their basic phenomena. So by having this, we have to consider about the basic thing regarding that of what? The how to add or subtract or multiply the vectors having different phenomena. In such a way, there are rules how we can add or subtract vectors. Not only subtraction, but also on the higher level, you also learn multiplication of vectors. And that of multiplication, there is also what? Basic rules. You will learn it. Now let's see the vectors that can be added having that of what? The dependency of direction. Unlike that of scalars, they will not added or subtracted arithmetically. In such a way, only vectors of the same type must be what? Added or subtracted. The first thing is only vectors of the same type, which are what? Added, like that of two forces. F net, which is the same as what? F1 plus F2. Here, the vector sum, which must be on that of what? Two forces. And also the vector sum also in that of what? Two velocities, like that of the net velocity or the velocity which is equals to v1 plus v2, having that of its direction, the direction. Okay, so by having this, you have to consider about what type of vector? The type of vector which is what? Which must be similar quantities, and the total or the resultant vector must have the same effects through that of what? The individual vector acting on a given body together. Okay, acting on a given body together. That's the resultant vector, which has what? The same property as the vector individual, which are acted on a given body together. You have to understand or think about this. What about the addition and subtraction having that of the scalar and vectors? The addition and subtraction having that scalar and vector. Without of addition without of scalar and vectors. When we add scalars, okay, we use arithmetic summation. Here, the sum of all here on that of scalars, which find having that of the summation of all ai runs from 1 up to n number of events on that of a scalar quantity, which are the same events, basically the same events. Then you can have what? We can have the arithmetic sum. Whereas in that of the vector addition, it doesn't account what? It doesn't account the arithmetic sum, because it needs the dependency of direction. It needs the dependence on direction. Whereas with that of the scalar quantities, like that of, for example, here, the increase in temperature, 5 degrees Celsius to 12 degrees Celsius. That's the increase in temperature. When it reaches to 12 degrees Celsius, 5 degrees Celsius to 12 degrees Celsius. So the increase in that result is having that of what? 5 degrees Celsius plus how much to get what? X. To get 12 degrees Celsius. Then X results what? 7 degrees Celsius. X results 7 degrees Celsius. In this case, simply it's an arithmetic step. Then 5 degrees Celsius plus what? 7 degrees Celsius. Okay? 5 degrees Celsius plus 7 degrees Celsius. Or by rearranging the given equation, you can have what? You can have X result is 7 degrees Celsius. Okay? 7 degrees Celsius. From that of 5 to 12 degrees Celsius. That is the reason why we add 7 to have what? 12 degrees Celsius. 12 degrees Celsius of what? Temperature. 12 degrees Celsius of temperature. So, in such a way where the vectors are added having the dependence of direction, the dependence of direction. Let's see the formulas. The resultant vector formula to that of what? A given vector to be added. The resultant vector, which is represented by that of R. Represented by having that of R. Where R is what? The resultant vector. R is the resultant vector. Is a resultant vector. So by having this, the resultant vector, that result is by adding two vector is this one. R is equals to the resultant vector R, which equals to A plus B, having that of its direction, having that of the depending on that of its direction. So the direction and the magnitude depends on the direction of the vector A and the vector B. The resultant vector direction, which depends on the magnitude of the direction of A and the direction of B. So, with that of the vector formula, with that of the vectors and the formula that we use, we can add geometrically in different form. Either it is a parallelogram rule, either it is a parallel rule, and also what? And also the triangle rule. We will discuss this on that of what? On that of the vector addition and subtraction using that of what? Using that of the graphical method on the next video. So let's see a simple example. To add two vectors. Okay? Two vectors. With that of the addition of vector here to have a resultant vector that A plus B. When A and B has same direction. Here the accent, which is in a short form of what? Direction. So mind this when you are dealing about what? Our discussion. So don't be confused. So by having this, if vector A and vector B is 8 meters per second north, what is the magnitude of what? The resultant velocity. So in our solution, vector velocity of A, which equals to 8 meters per second north. Here, mind you. And the vector velocity of B, which result is what? 8 meters per second north. Here, when you see these two, vector A and the vector B, the velocity of A and the velocity of B, which has what? Which are in the same direction. So by having this, we can simply add them. By having that of what? Their direction. So in this case, the resultant velocity, the velocity resultant, which result is what? The velocity of A plus the velocity of B, having that of the same direction. So simply 8 meters per second plus 8 meters per second, both are what? In the direction of north. Then adding the two, it results what? 60 meters per second due north. So the vector A and vector B, which has 8 meters per second to north, then the resultant velocity of the vector A and B results what? 60 meters per second to the north. To the north. So by having this, in this case, the direction of the resultant velocity, which depends on what? The direction of A and B. A and B. So this is the basic thing that you have to do without what? Addition of two vectors, like the velocity vectors, like that of force vectors, like that of displacement vector, like that of momentum vectors, and so on, and so on. You will deal it when you go to the higher level. The other thing is when we have what? The vector subtraction. And that of the vector subtraction, it is also called what? Adding of a negative vector. Adding of a negative vector or an opposite vector. So by having this, the resultant vector which results what? A minus B. Or which is the same as? Or the resultant which is equals to what? A plus minus B. A plus minus B. Here it is. A minus B is the same as what? A plus minus B. A plus minus B. In this case, to subtract B from A, that the reverse direction of B, which is added to what? A. The reverse direction that we have to change. For example, if the vector A which equals to what? 8 meters per second to north and vector B which equals to 8 meters per second to south, then we have what? This is the same as 8 meters per second minus 8 meters per second to north. 8 meters per second to north. Okay? meters per second to north. Then after here, when we have the resultant velocity, here the resultant velocity of A and B which equals to what? The velocity of A plus minus the velocity of B. Minus the resultant velocity of B. So by having this 8 meters per second to north minus or plus minus 8 meters per second to north. So by having this result is what? 0. This result is 0. So in such a way, you can find that how you can subtract vector. In such a way, for example, here, vector A which has what? 7 meters per second north and B which has what? 4 meters per second south. In our solution, that you have to take that A which equals to what? The velocity of A which equals to the velocity of A which equals to the velocity of A which equals to what? 7 meters per second due north and the velocity of B which equals to what? 4 meters per second due south. Then this result is minus 4 meters per second due north. Then by having this, the resultant in our solution imply that the resultant velocity of these two vectors, which result is velocity of A plus minus the velocity of B, is the same as the velocity of A which equals to 7 meters per second to north plus minus 4 meters per second to north. In such a way, we have what? 3 meters per second to north. So therefore, that the resultant of the velocity A and B, which is equals to the velocity A and B, which is equals to 3 meters per second to the north. Here, the direction of the vector on that of this vector subtraction depends on the maximum magnitude of what? The vector. The maximum magnitude of the vector. Here, on that of the magnitude, which is maximum on that of A, 7 meters per second, than 4 meters per second. If we rearrange or just change like that of for example, if the velocity of A, which equals to 4 meters per second due north, and the velocity of B, which equals to 7 meters per second due south, then this result is minus 7 meters per second due north. Then we have what? The resultant velocity. The vector resultant velocity of A and B, which equals to the velocity of A plus minus the velocity of B. Then the result is the velocity of A 4 meters per second north plus minus 7 meters per second north. Then the result is minus 3 meters per second north. Or then the resultant velocity, which equals to what? 3 meters per second south. 3 meters per second south. So the largest magnitude on this vector is the vector on B, the velocity of B, which is what? 7 meters per second. That of what? 4 meters per second, which is largest than 4 meters per second. So by having this 3 meters per second south, the velocity of a given resultant depends on what? In that of the vector subtraction, it depends on the maximum individual velocity. So by having this is the basic thing with that of the vector subtraction. So by having this, what we see today is about how we add, or the summation of vector, and also how we subtract, or the difference of what? Vectors. In that of the vector addition, it mostly or always depends on the magnitude and direction. Basically about its direction. Whereas in that of the vector subtraction, it's an addition of the negative vectors. Or an opposite vector having that of its magnitude. Whereas in that of the vector addition or subtraction, we always have to consider about the vector of the same quantity. The same physical quantity must be what? Added. Like that of 2 or more than 2 forces, 3 or more than 3 velocities, or 2 or 3 or more than 3 velocities, 2, 3 or more than 3 momentum, electric fields, and so on. So we can add or subtract having that of what? Having that of the quantity that must be what? The same. So you have to consider about it. So on the next video, we will do this review question: what meant by subtraction of vector and what meant by the resultant vector. Okay? እስካሁን ስንመለከት የነበረው ቬክተር አዲሽን ኤንድ ሰብትራክሽን ነው ማለት ነው። በሚቀጥለው ቪዲዮ ሰፋ ያለ ማብራሪያ ይዘን ሴክሽን 1.4 graphical method of vector addition and subtraction የምናየው ይሆናል። ነገር ግን እንደ ሁሉ ጊዜው ዌብሳይታችንን፣ የዩቲዩብ ፔጃችንን፣ በተጨማሪም የቴሌግራም ቻናላችንን እየተቀላቀላችሁ እየጎበኛችሁ ሐሳብ አስተያየታችሁን አጋሩ። እስካሁን አብሬያችሁ ነበርኩኝ። እኔው ነኝ የ10ኛ ክፍል የፊዚክስ መምህር ከሉሲ ብሪጅ አካዳሚ። ደህና ቆዩኝ።